I'm going to be showing you how to use the normal distribution in a Statistics 1 exam question. So I'm just going to share my screen with you to show the question in hand. So what we have here is a normal distribution question. In an exam situation, it's pretty obvious whether you're dealing with the normal distribution. It generally tells you at Statistics 1. So here we're told that the weights, W grams, of kiwi fruit grown on a farm are normally distributed with mean 80 grams and standard deviation 8 grams. Now, examiners like you to write this distribution in its proper form. So what you need to do is write that as X tends to be normally distributed with mean 80, standard deviation 8, because the parameters for the normal distribution are the mean and the variance. And by showing this in your exam paper, the examiners know that you're on the right lines for what you're talking about. Okay, so here we've got a table of classification of different kiwi fruit by their weight. We're given all the information we need apart from this random constant K. We don't know the size for jumbo. We know it's between 80 and K, and therefore we don't know what mega is. It's greater than or equal to K. One kiwi fruit is selected at random from those grown on the farm. Find the probability that this fruit is large. So for part A, we want the probability of picking a large fruit. And if we go to our table, we can see that the boundary for large is 70. So therefore, we're being asked for the probability that W is greater than or equal to 70. Now I always draw a diagram with my normal distribution, a very quick sketch, just to help me know exactly what area I'm talking about. We know that the mean is in the middle. Just put 70 in. And what I know is I'm talking about this area here. Now this should guide you because this tells me that the answer we're expecting is greater than a half, because anything greater than the mean is a half. Anything below the mean is a half. This 70 is to the left of the mean. So therefore our answer is going to be greater than a half. So let's work out our probabilities. Now I'm assuming that we're going to do this without the special calculator functions, because you can do this on a calculator very quickly, but not everybody has the calculator. So we're going to use this the proper way of showing the full method without using the special calculator facility. So the first thing I need to do is work out what this represents, this 70, what does it represent in terms of standard deviations away from the mean? So we standardize it. We find what's called Z. And Z is equal to X minus mu over sigma. So in this case, our Z is 70 minus 80 divided by 8. So I've got a Z of minus 1.25. Now, what we would normally do at this point is we would look up in the tables what probability that Z represents. But there are no negatives. Here's our table here. There are no negatives in there. But we use the fact that the normal distribution is symmetrical. And just very quickly, if I've got this value of Z over here, that will be negative. But at the same end over here, let's assume they're the same area, and I've drawn that exactly the same way. That will have the same value, but it will be positive. And that's the beauty of the normal distribution. We can use the symmetry of it. So instead of looking up minus 1.25, I'm going to look up positive 1.25, which is here. So there's a Z column, 1.25, and that gives me the 5Z as 0.8944. So I'll put that in there. Now, Normally, we would correct this negative. We would correct it because we have to adjust for the fact that we have not used the negative form of the Z. However, these tables work on the assumption that we're working out a less than or equal to, or a less than probability. But we were working out a greater than probability. So we adjust for the negative, but then you adjust again for the greater than, which corrects itself. So in fact, we don't need to make any adjustment in this particular case. So therefore, the probability of picking a large kiwi fruit is 0.8944. If you do use the calculator function, and as I say, you can use the calculator for this, the examiners like to see it as at least as accurate as the tables are. So in other words, show more decimal places if your calculator provides you with those. Now, the next thing that we need to find is part B. We're going to find the value of K. Now it says 35% of the kiwi fruit are jumbo. So here's jumbo between 80 and K. So I'm going to do another quick sketch. And it tells me that jumbo is actually from the mean up to some value K. And it tells me that that area represents 35%, 0.35. So I know the probability of being between 80 and K is 0.35. But I know something else as well, because I know the area to the left of the mean is 0.5. So therefore, the probability of being less than K, so W being less than K, is equal to 0.85. So what I do at this point is I use the reverse table up here, and I'm going to look up 85%. But again, you see that it doesn't include all the probabilities in there, and that's because of symmetry again. 85% is going to be the same value as 15%. And 15% is 1.0364. So I know my Z is 1.0364. Now at this point, you need to ask yourself, is Z positive or negative? Because these tables don't tell you. And it's very easy. If your value for X is greater than the mean, then our Z is going to be positive. If our value for X is less than the mean, then it's going to be negative, and our value is going to be positive here. So now I just need to put it into table form. K minus 80 over 8, and we know that that equals 1.0364. So that tells me that my K is equal to 88 point, now it says one decimal place, 88.2 to one decimal place. True value there from the calculator, 88.2192. But I always read the accuracy that they want it given in. Now, generally with normal distributions, and not all the time, but for a good number of years, the first two questions have been reasonably straightforward. The third question tends to start delving into conditional probability. Not always, but it's something to look out for. And this case is no exception. It says 75% of tiny kiwi fruit weigh more than Y grams. Now, you might not see this straight away, but this is conditional probability. It's basically saying that given that we're looking at tiny fruit, the probability of being greater than Y is 75%. So let's put that into a diagram. So there's my 80 again. So here's my tiny down here. Now I know the tiny is from 66 downwards. And what we're basically saying is just looking at this particular area, just this yellow region in here, if we've got Y in there, then 75% of the yellow is greater than Y, which means 25% of the yellow is less than Y. Now that's very important that you understand that that's just looking at the yellow region. It's not looking at the whole area. Okay, this is just looking at tiny fruit. So putting this into calculation form, what we're saying is that the probability that W is less than Y, given that it's tiny, is equal to 0.25. Now, we don't know the probability of being tiny yet, so I think that's the first thing that we're going to have to do. The probability of being tiny implies the probability that W is less than 66. I'm going to find Z again. Z, 66 minus 80 over 8. Now, I know Z is going to be negative because it's to the left of the mean, and it is minus 1.75. So I look up the phi of 1.75. Remember, we've got to look up the positive, and that is 0.9599. How did I get that? Well, I went to my tables, and I went 1.75 there. Now, we need to correct the negative, and it is a less than question. So therefore, we want 1 minus 0.9599, which is 0.0401. I'm not going to do any rounding at this point. Just as a matter of course, with the continuous distribution like this, less thans and less than are equal to's, they're the same. It's negligible difference. So never worry about making any adjustments for that. So now we know that the probability that W is less than 66 is 0.0401. So here's what I've got. I've got the probability that W is less than Y, given that it's tiny, which I know is 0.25, but that is the probability that W is less than Y over the probability of being less than 66. So we know that that's the probability that W is less than Y. Let's bring this down a bit. Divided by 0.0401. And we know that that equals 0.25 because it represents that little section in there. And if I rearrange that, I get that the probability that W is less than Y is 0.010025, approximately equal to 0.01, 1%. So now I know my probability, I need to find out what Z is. So if the probability is 1%, my Z, I'm going to go up to my tables here and look up Z for 1. And you can see here, it's 2.3263. Now, this is where you can easily get caught out. Remember that your Y is to the left of the mean, so it's a negative. All I've got to do now is put this into my standardizing formula. I don't know why. I do know everything else. And that tells me that Y is equal to 61.4 to 1 decimal place. Just take the 8, multiply it by the minus 2.3263 and add 80. Your final step is to just check that that looks right. If I've got an answer greater than 66, for instance, I know that can't be right. Look at my answer 61. It looks in the right region, confident that that is the correct answer. Again, you can check all these and do all these on your calculator if you have the Casio FX 991EX, but this is the full method, assuming no calculator is available. I'm going to be showing